Welcome to another section of Chapter 5. We've pretty much covered numbers. We talked about numbers in terms of scientific notation. We've talked about numbers with sig figs, and now we're ready to tackle the second part of a measurement, and that's a unit. And if you will recall that all measurements, all of them, all measurements come with two parts. The first part's a number, which, like I just said, we've talked about, and now we're ready to tackle the part about units. Units are a funny little thing. They're completely man-made, made them up. Yep, we did. And we used to use some very strange units. For instance, this distance between the elbow and the fingers was called a cubit. I'm sure it's still called a cubit, but I don't know anybody who still uses these. And some of you might remember this one, because this one's still used for measuring horses. You measure horses by hands. Now, I know there is an actual standard one hand, whoops, wrote that in the wrong spot. One hand is equal to X number of centimeters. I don't know what that is. I'm not a horse person, but you can clearly see that if somebody had with small hands and somebody with large hands, you're going to get a different measurement on the height of the horse. And I know you do measure the horse from this point on their shoulder down to the hoof, and that's measured in hands, and it's still used today, only it has been standardized. A foot was actually the king's foot, sure enough, and you'd have to reassess whether or not you had a king with a big foot or a large foot, and it affected everything because the standard changed when the king changed. Same is true with a yard. It went from the distance of the king's nose to the tip of the finger. And again, that would change as we got a new king in. Now, mind you, this is pretty much the European view on old-fashioned units. I've totally ignored the Asian view or the Arabic view. They all had their own set of standard units also, which were completely different from these. Then a group of people got together and decided, you know what, we really need to have a standard. Something that the same language we all speak. Unfortunately, America is the only one still left with that old-fashioned system I kind of mentioned a minute ago. So, these are the fundamental common SI units. When I say the length of something, you should know that length is meter, and that we abbreviate meter as M. Time, that one's easy, that's seconds. Mass, the standard SI unit for mass is a kilogram, and it's abbreviated as kg. However, we will be using gram most often because that's the base unit. Temperature, the common SI unit is Kelvin. We will use both Kelvin and degrees Celsius. Degrees Celsius is used quite a bit for reasons that I'm not going to go into right now, but we do use both. Please notice on the Kelvin symbol there is no degrees sign. See that? Don't do it. The metric system. Hopefully, by the time you're done with me for chemistry, you'll find this system to be a lot easier to use than the American system. Unfortunately, folks, you got to learn both since we use both in this country. Wish we didn't, but nobody asked me. One of the base units you need to know is a meter. I mentioned it in the slide before. The symbol for this is meter. And when I say symbol, by symbol, I mean this is what we put at the end of our number. So if I say 14 meters, you would write it like that. It measures length. And I'm going to use the symbol L for length. This does not go at the end of a number. This is how we represent the variable. In a chemical equation, you should be familiar with volume equals length times width times height. And the L is what we would put here. But if I were to actually measure the length of something, the symbol then is a meter. Gram, the symbol we use for gram. Anyone? Yeah, G. And that measures mass. A liter, its symbol is an L, and that measures volume. And those are the basic units we're going to cover in this chapter. This is the sentence you really need to know to be able to convert within one metric prefix to another. This sentence will only help you within the metric system. It will not help you get from the American, or rather the English system, to the metric system. Those numbers are bizarre, but the metric prefixes are all based on a single number. It's really, really easy. And you're rolling your eyes at me, I get that. But anyway, we've got King Henry died by drinking chocolate milk. So king, that stands for the prefix kilo. Henry, hecta, died would be deca. Notice those are all capital letters. By is your base unit. Drinking is deci. Chocolate, centi. And milk is a milli. The three base units we've discussed: meter, gram, and liter. So we'll see how all these fit together. The metric prefixes will help you because everything is based on a factor of 10. All of it. It's all based on 10. If you can multiply and divide by 10 or move the decimal, you're good to go. So let's take a look. Our base unit, we're going to assign the number 1. One step over is based on a factor of 10. So it's one step over, so it becomes 10 to the first power. So I can say there are 10 grams in 1 decagram. And you're looking at me going, okay, I thought you said the base was 1. I'll explain how this fits. Hold on. But basically the point is of this slide is to show you that every time you shift over by a power of 2. And if I go the other direction, I'm going to divide by a power of 2. If you recall, that negative sign means division. But there's actually an easier way to do it than even this. Okay, so let's try a couple examples, how this fits together. The good news is if you follow the method I'm going to present to you, you never have to deal with negative exponents. So just deal with that right now. We're always going to deal with positive exponents. Here's our first question. How many meters are in a kilometer? So the first thing is you write down King Henry died by drinking chocolate milk. Well, you don't have to write down all the words. Most kids just at the top of their papers write King Henry died by drinking chocolate milk. Please note that on the left side of this, where the letters are capital, these units are the bigger units, and these are the smaller units. That's a helpful tip here. Okay, base unit, meters. That's where we're starting. We're starting with meters. So if you'd written King Henry died by drinking chocolate milk, you could put a little check mark here because that's where we're starting with the base unit. And we're heading over to a kilometer. And that's, then you can put a little check mark here on the kilo. All right, that's what we're converting between. And the question is, well, how many meters are in a kilometer? Well, if we'd written King Henry died by drinking chocolate milk, we know we're at the base, we're going to the kilo. So which of these units is bigger, the kilo or the base? Yes, the kilo is bigger. So that one, we're going to assign it a number 1. Then your biggest question to answer is, well, how many powers of 10 to get to the meters? Well, we've got King Henry died by drinking chocolate milk. It's really important to me that you know this. Yes, we're going from king to the base. So how many steps to go from here to there? Let's find out. You don't count the step you start on, so there's 1, 2, 3 steps. And because this is all based on a power of 10, 1, 2, 3, we can say there's 10 to the third meters in 1 kilometer. Let's practice converting between one metric prefix and another. Well, okay, we're not really converting today. All we're doing is we're finding conversion, oops, wrote that in the wrong spot, conversion factors. These are equivalent statements. Equivalent statements. So what I mean by equivalent statements is that one side of our equal sign will equal the other side, and this will allow us to use these conversions when we actually convert from one unit to another. Say we start with 12 meters and I want to know how many kilometers there are. these are the conversion factors that will allow us to do that. So let's practice between a kiloliter and a milliliter. To begin with, we need that sentence. Yeah. What's that sentence again? Oh, wait. Pause the video. Jot it down. See if you can remember it, because you really, really need to know that sentence. Okay, here we go. Did you get it? I keep writing on my ink. King Henry died by drinking chocolate milk. And the first one we're going to do is this one. Whoa, that K is lowercase. I thought you said K. This is what I think you're saying, is I thought you said K was capital letter. Yeah, it is. Unless, of course, the base unit that we're starting with, in this case liters, is capital, and then they decide it's a good idea to flip them so that it doesn't look stupid, this capital K, capital L. But K does mean kilo in this case. So, kiloliter. If you wrote capital K, capital L, I'm not going to dock you. I mean, it's fine. I want you to go through the process. Can you do it? That's more important to me. So, between a kiloliter and a milliliter, well, let's see. What's the first step? Identify where we are. All right, we're at the kilo, and we're going to a milliliter. And that's this one. Remember, our three base units are, see if you can jot them down. Pause the video. Okay, we have grams, liters, and meters, not to be confused with this little m, which is milli. All right, good. So, who's bigger, a kiloliter or a milliliter? Who's bigger? Good, yes, the kiloliter is bigger, so we're going to give that a 1. 1 kiloliter equals. Now, this whole system is based on what number? Correct. It's based on the number 10. So we just need to count our steps so we can figure out what exponent goes here. Now remember, if you give the bigger unit the number 1, you never have to deal with negative exponents. So how many millimeters are in a kilometer? So now we're just going to count our steps. And I'm going to change my pen color to make it a little more clear over here. So it doesn't matter which direction you start, just don't count the step you're standing on. So we have 1, 2, 3, 4, 5, 6. So your correct answer is 10 to the 6th. I'm going to go ahead and erase all this ink, and you try this next one on your own. Pause the video and give it a try. And if you feel, hey, Norton, I'm not there yet, I need another example, don't bother pausing, just plow on forward. I have more examples coming. Okay, so you need that sentence again. That's part of why I've cleared all the ink. So the sentence, King Henry died by drinking chocolate milk, are 3 base units. And it's a good idea to write these down for a while until you're really comfortable with them. And I don't care what order, grams, liters, and meters. Please remember this is milli, not meters. This one's meters. I know, clear as mud. And I'm sure you're thinking, Norton, I thought you said this was easier. Okay, it is, trust me. All right, millimeters to centimeters. So let's see, where are we starting and where are we ending? Well, we're starting with the milli, so that's here, and we're ending with the centi, or the other way around, it doesn't matter. But which one's bigger, a centimeter or a millimeter? Remember, this side's bigger, this goes then to smaller. So the centi's bigger, so I'm going to go ahead and give that the number 1 centimeter. And the question is, it's going to equal how many then millimeters? This whole system's based on the number 10. So now we just have to find out what this exponent is. How many steps between a centi and a milli? 1 step. So there's your answer. 1 centimeter is equal to 10 to the first power millimeters. And you've got the conversion factor. Go ahead and pause the video after, oops, let me erase the ink. Yeah, so you don't need that. You can do this. So let's erase all the ink, erase all the ink on the slide. Okay, give this one a try, see what you can do on your own. If you're still thinking, Norton, I'm not ready yet, that's fine, just plow forward, but go ahead and pause it. Okay, so we're going to write that sentence again. King, wherever my pen went, there it is. Nope, not there. King Henry died by drinking chocolate milk. We're going to start for a while, write the bases in. So we've got meters, grams, liters. Yeah, I mixed them up on purpose. We're starting with grams, so that's a base unit, and we're heading towards hectograms. That's here. So which is bigger, a hectogram or a gram? The hectogram's bigger, so I'm going to give that the 1. 1 hectogram is going to equal 10 to the something grams. So let's find out what that exponent's going to be. 1, 2 steps between them, so 10 to the second grams for every 1 hectogram. I just found a conversion factor. Yay! Okay, give these next 3 a try on your own, and tomorrow when you come into class, I want to see how you did. And as you can tell by the top, these are worth bonus points. Give those a try. Now that I hope you are feeling more comfortable converting within the metric system, of course, I am going to make this a little more difficult because this is where we're going. To be able to convert something like from 6 miles per hour to 2.7 meters per second. And I know you're going, what? Don't worry, don't worry. We'll get there. That's coming in your next video. Have a great night.